Hello and welcome to the Answer Series Natural Sciences videos based on our study guides. In this video, we will practice what we have learned throughout this topic by working through an exam type question. The question says that the pictures A to F show some planets and other objects that occur within our solar system. And it's important to note that the pictures are not drawn to scale. This means that some of these objects might be larger or smaller as they're not represented in their exact size in these pictures. So we need to look at the observable characteristics of what is provided in order to identify what planets and what objects we are viewing. Pause the video here and try to answer questions 1 to 5 yourself before we continue through them together. Question 1 asks us to give only the letter or letters of the pictures that show a star, a terrestrial planet, and the Earth. So looking at the pictures provided, we can see that C is our sun, and we know that the sun is the nearest star. It's also the only star in the pictures provided. The rest are either planets, moons, or asteroids. So C is our sun. Terrestrial planets are the first 4 planets closest to the Sun: Mercury, Venus, Earth, and Mars. Of those, the one that is most obviously a terrestrial planet shown here is Earth, which has that solid surface, making it a terrestrial planet, and that is therefore D. Question C asks us to identify the picture that shows the Earth, and that's an easy one because we know that that one shows us home, also number D. Question 2 asks us to give 3 ways in which you would be able to distinguish between a star and a planet. So this is something that we recapped in the slides, and it's learning work. Stars will twinkle whilst planets will shine with a fixed glow. Stars emit their own light, think of our sun, whereas planets will only reflect the light that fall on them. They don't emit their own light. Stars are much larger than planets, and stars keep their positions in the night sky, whereas planets change their positions. So the question asked you for 3 things that we can use, or 3 ways to distinguish, and we have provided 4 on the memo. So any 3 would be accepted, but importantly, only the first 3 will be marked by the examiner. Question 3 asked us to identify the planet shown in A and to give a visible reason for our answer. So looking at planet A, we notice a specific visible characteristic, which is that nice red dot on the surface of the planet, which helps us to identify planet A as Jupiter. And that red dot helps us to identify it because that is the eye of Jupiter, a giant hurricane that's moving over the surface of the planet and one of the characteristic features of this planet. Question 4 says that planet F is identified as Saturn, and it asks us first to give 1 visible reason for this identification. So looking at Saturn, one of its most characteristic features is the fact that it has those beautiful, clearly visible rings around the planet. Then they ask us to provide any 2 other characteristics of Saturn, and there are a number of them to choose from, as discussed in the video on the characteristics for gas giants. Any 2 of the following would be considered characteristics of Saturn: that it is the 2nd largest planet, that it is a gas giant, that it has 62 moons, that it's very light, so it's the lightest planet, or you could have said that it can float in water, or that it has a lower density than water, that its average temperature is a minus 140 degrees Celsius, that 1 day on Saturn is equivalent to 10 hours on Earth, or that 1 year on Saturn is equivalent to 29 Earth years. So any 2 of those, and again, the examiner will only provide marks for the first 2 answers that you have provided. Question 5 says that picture B shows a natural satellite. First, they asked us to give an alternative, more common name for a natural satellite. And from the videos that we've studied, we know that that is called a moon because it is a naturally occurring structure that acts like a satellite that orbits around a planet or even some asteroids. Then they ask us how many natural satellites does Mercury have compared to the planet in A. So they're basically asking us to compare the number of moons for Mercury to the number of moons for Jupiter. So you get 2 marks for this because you have to say what are the number of moons for Mercury and then what are the number of moons for Jupiter. Mercury has no moons, whereas Jupiter has 79 of them. Pause the video here and try to answer questions 6 to 9 yourself before we go through them together. Question 6 says that the picture E shows an asteroid. First, they ask us to name one place in our solar system where asteroids occur, and that's an easy one because it's actually called the asteroid belt. So that's the space between Mars and Jupiter. Then B asks us to explain how asteroids relate to meteoroids. So explain how these two terms relate to one another. So in video 2 on the solar system, we discussed that asteroids occur in the asteroid belt between Mars and Jupiter, and these metal-like pieces of rock orbit in that belt until they collide with one another. And sometimes smaller pieces break off, and they then move out of the asteroid belt and start accelerating toward whatever planet is closest. And these free-floating rocks in space are what we call meteoroids. So asteroids, to a large extent, actually relate to meteoroids because they give rise to them. They are a source of meteoroids. So if we look at the memorandum, a good way of phrasing your answer would be when asteroids collide inside the asteroid belt, smaller pieces can break off and move out of the asteroid belt. These free-floating space rocks are smaller than asteroids and are called meteoroids. So asteroids are therefore a source of meteoroids, or they give rise to meteoroids. And that explains how these two terms are related to one another. Question C then asks us to explain why a meteor is often mistakenly called a falling star. We covered this in video 2 of our solar system, where we said that meteors are basically meteoroids that have moved into the atmosphere of a planet. And because the atmosphere of a planet has lots of gases in it, it starts to burn up. And this burning process then creates this long white tail that ultimately resembles a star falling out of space. And that's why people tend to refer to them as falling stars. So to phrase that correctly in the form of an answer, you would start by saying that a meteor is a space rock and it enters a planet's atmosphere. There's friction between the meteor and the gases in the atmosphere of the planet, causing it to burn up, and that burning action creates this long white streak behind the meteor. And because that streak appears and disappears very quickly, it creates this impression of a star falling out of space. Then question 7 says to give only the name of the hottest and also the coldest planets in our solar system. So this is not related to the pictures provided, but needs to be recalled from memory. And this is easy because you just need to remember the sequence of the planets. So the planets closer to the sun will be hotter. Of those, Venus has the conditions that makes it the hottest planet in our solar system. And then the planet furthest away from the sun, Neptune, will be the coldest. Question 8 says to provide 2 sources of comets that occur in our solar system. In video 3, we discussed the Kuiper Belt and the Oort cloud as the 2 sources of icy rocks that move towards the sun, creating these long, white, hairy tails as they melt over millions of years. So that is the answer to question 8, the Kuiper Belt and the Oort cloud, the 2 areas that create comets. Question 9 lastly asks us to explain how the Earth's average temperature makes it the only planet in our solar system that can support life. So here we're specifically going to comment on the temperature range and how that affects life on our planet. So Earth has an average temperature of 16 degrees Celsius, which is not too hot and not too cold. It's just the right temperature. But what is it just right for? Water. That is the key to life. That temperature range allows for water to appear in a gas and a liquid and a solid state on our planet. So living things need water to survive. Your body is more than 70% water. So if the Earth were too hot, like for example all the other terrestrial planets, then all the water would have evaporated. And if the Earth were too cold, like the gas giants, then all the water would be frozen or inaccessible to life. So it's really about how the temperature range allows for water and how that water then can sustain and support life. So there you have it, a typical exam question based on the content covered in this topic. It's not nearly all the types of questions you can see, but it gives you a nice overview of what to expect. Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.